Welcome to the session on Algebra 2, Graphs of Lines. And what we're going to be doing today is finding the x and y intercepts of a line given the equation of the line, determine slopes of lines given the graph or equation, and draw graphs of lines given the equation. First, we're going to refresh our memories on slope-intercept form and standard form. Slope-intercept form is y equals mx plus b. If you remember, m represents slope, and b represents y-intercept. Standard form is ax plus by equal to c. So you can take any equation and you can write it in slope-intercept form, and you can also write it in standard form. For standard form, the a, b, and c all represent numbers. The a and b represent the numbers that are multiplying x and y, or the coefficients of x and y. And I'm just going to talk about slope for this. You can quickly find slope when the equation is in standard form by creating a fraction with the coefficients of x and y. But it's going to be the opposite, or the negative, of that fraction. So it'll be negative a over b for finding the slope. And if you need to pause, remember in the lower left-hand corner you can do that. Graphing. When we're graphing, we can do one of three things. We can create a table, which your lesson does focus on, which I'm not going to go over today. You can use x and y intercepts. You can use the y-intercept and slope. I'm going to talk about these two today. Finding intercepts and graphing. An x-intercept is a point on the graph where y is 0, or the graph crosses the x-axis. So if we look at this graph here, you can see that the graph crosses the x-axis right here. That point is 4, 0. So we say 4, 0 is our x-intercept. The point where the graph crosses the y-axis is called the y-intercept, and that happens at 0, 3. So 0, 3 is our y-intercept. Now, it's important that you put these numbers in the correct spot. For an x-intercept, the y is always 0, and the x value is the first number. For the y-intercept, the x value is always 0, and the y value is always the second number in the parentheses. So let's take a look at some problems. Find the x and y intercepts and the slope of the equation and graph it. So we're looking at 2x minus 6y equal to 12. The first thing that we're going to focus on are the x and y intercepts. This equation is in standard form. So to graph it, it is most of the time easier to use the x and y intercepts. So to find an x-intercept, as we were saying before, when you're looking for an x-intercept, your y value is 0. So what we're going to do is we are going to replace the y value here. Let me get a better pointer. We're going to replace the y value with 0. So what we'll have then for this equation is 2x minus 6 times 0 equal to 12. So we replace the y value with 0 and we solve for x. So we get 2x, 6 times 0 is 0, so we have 2x equal to 12. Divide both sides by 2 and we get x equal to 6. So the x-intercept is located at 6, 0. To find the y-intercept, we make x equal to 0. So now we are replacing the x value with 0. So we will have 2 times 0 minus 6y equal to 12. And you want to watch your signs here, guys. The negative or the minus sign in front of the 6 needs to stay with that number. 2 times 0 is 0. So we will have negative 6y equal to 12. Divide both sides by negative 6, and we get y equal to negative 2. So we have a y-intercept at 0, negative 2. Now I'm going to use those 2 points to make a graph of this equation. 6, 0 will be right here. And 0, negative 2 will be right here. And then I can draw a line between the 2 points. And that's my graph. Now, I didn't find the slope yet, so we do need to do that. If you remember, I said when an equation is in standard form, you can find the slope by creating a fraction, negative a over b. So a represents the value multiplying x, which is the 2. B represents the number multiplying the y. Keep the sign in front of the number with it, so it's a negative 6. But then we also have this negative sign here as part of the formula, so we need to include that. So we get negative 2 over negative 6, which is a positive 2, 6. And that reduces to 1/3. So our slope for this graph is 1/3. And if you're not sure what slope means, we're going to talk about that shortly. Moving on, let's find the x and y intercepts and the slope for this equation. Y equals 5 minus 3x. Well, we want to take a look at it and decide, is it in standard form or is it in y slope-intercept form? And it's solved for y. So if you remember, an equation that is in slope-intercept form is solved for y. It has the 5 first, so I'm just going to rewrite it, keeping the negative with the 3. So negative 3x plus 5, it is in slope-intercept form. So let's write that next to it. I could write it in standard form if I wanted to, which would make finding the x and y intercepts easier, but I am going to show you how to do it when the equation is like this. Finding the slope in the equation is like this is very quick and easy. Let's do the slope first. So in this form, the number multiplying x is your slope. So our slope here is negative 3. The y-intercept is just as easy to find. When it's in this form, slope-intercept form, the number being added or subtracted to the slope is your y-intercept, and it's a positive 5. So our y-intercept is 5. And we could also write it as 0, 5 for the point. So the point is at 0, 5 for the y-intercept. And to find our x-intercept, we're going to do what we did on the last problem. We're going to make y equal to 0. So we'll have 0 equal to negative 3x plus 5. And now we have to solve this equation for x. So I'm going to subtract 5 from both sides. That will give me negative 5 equal to negative 3x. Divide both sides by negative 3, and you get x equal to negative 5 over negative 3. Now, 2 negatives will give us a positive, so we want to make sure that we finish by making it a positive 5/3. So our x-intercept is at 5/3, or we could write it as the point 5/3, 0 for our x-intercept. So, easy to find slope and y-intercept when it's in slope-intercept form. Not as easy to find the x-intercept, but you could change it so it's in standard form, and you could find the x and y-intercept that way, and the slope. So the forms are interchangeable. You can change equations so they are in either one form or the other. Whichever you find easiest to work with is probably the better way to do it. Let's take a look at this one. We're going to identify the slope and the y-intercept for this equation, and then we're going to graph it. So it is solved for y, so that means that it is in slope-intercept form. The slope is 2/3. And the y-intercept is -3, or as an ordered pair, 0, -3. Now, how do we graph this? Well, we start out by graphing the y-intercept. So our y-intercept is at 0, -3. Let's write that step down. First thing we do is graph the y-intercept. Our second step is to start at the y-intercept So the next thing you're going to do is start at the y-intercept, and you're going to move up or down and left or right. So how do I know? Am I moving up or down? Am I moving left or right? What do I do with these numbers, 2 and 3? Well, slope is rise over run. So the top number, the 2, represents the rise. Okay? So if it's a positive number, you're moving up. If it's a negative number, you're moving down. It's a positive 2, so I'm going to go up 2, which will put me right there at -1. And then I look at the denominator, or the 3, to tell me if I'm moving right or left. If the 3 is positive, I'm moving right. If it's negative, I'm moving left. So it is a positive 3, so I'm going to count over 3. So that'll put a point right here. So to determine, you can determine however many points you want using this method. It's basically you're doing steps. So I'm going to go up 2 and over 3 to get another point. And that'll give me another point for my graph. And you can see that it creates a step-like pattern. So this point is at 0, -3. This point is at 3, -1. And this point is at 6, 1. So that gives us our graph, and then I can connect the points. Usually you need 3 points, 2 points if they're both intercepts. So there's my graph. Now, if you want to find points below your y-intercept, you can just reverse the direction that you went when we were finding points above the y-intercept. So you would go down 2 and to the left 3, down 2 and to the left 3 to find points below. So let's write down here for rise. If it's positive, you're moving up. Negative, you're moving down. And we're talking about the sign of the number. If the denominator is positive, you're moving right. And if it's negative, you're moving left. So usually what I do, if I have a number such as -3/5, I make sure I keep the negative sign with the numerator, and so my denominator is almost always positive. So it's usually my numerator that could be positive or negative. All right, moving on to one last problem. We're going to take these two graphs and we're going to identify the slope and the y-intercept. So the y-intercept is the quick one to get. All we need to do is look at the graph and we can identify where the graph crosses the y-axis. So where the graph crosses the y-axis is our y-intercept. So if we look at this graph, and I apologize if it's hard to tell the way that it's numbered. So 1, 2, 3, 4, 5, 6. The y-intercept is at 6 or 0, 6 for the ordered pair. Then the slope. What you do for slope when you're looking at a graph is you basically pick a starting point. So I'm going to start with the point here. And what I'm going to do is I'm going to count up and over, or you could go down and over, but you're trying to find a place on your coordinate plane where your graph crosses an actual number. So what we're going to do is we're going to count up and over to find the slope. So I'm going up 2 places and over 1 to hit a point. That's a whole number or an integer. I'm going up 2, oops, not very straight. Let's try that one more time. I'm going up 2 and over 1 and up 2 and over 1. So the pattern is you're going up 2 and over 1 each time to hit an integer on this graph. So for my slope then, I'm moving up 2 and to the right 1. So when I write my slope, remember it's rise over run. So the rise number is 2 and the run number is 1. So my slope is 2 over 1, and I can reduce that to a 2. Then for the next graph, I pick a starting point. And really you could go, if you wanted, you could go from this point all the way up until you reach this other point. And then you would still get an answer of 2, but you would have a fraction to reduce. So let's do that on this one. I'm going to go all the way up until I hit the line that's horizontal with this point. So that'll bring me up here all the way to the x-axis. And then I have to go to the left to hit that point. So that is a change. The rise is, oops, 1 second. The rise here is 3, and the run is 4. Now, what I have to pay attention to is the fact that I went up 3, but I went to the left 4. So that makes that 4 negative. So when I write my slope, the rise is 3, the run is negative 4. So that gives me a slope of negative 3/4. And then my y-intercept here, we can easily tell from looking at the graph, the point where it crosses the y-axis is at negative 3. So it's 0, negative 3 for my y-intercept. And so I'm very quickly going to show you on this graph again how to find the slope if we just use the 2 points that were given. So you can see that it is a 2. If we go up until we reach the horizontal line for our point on the graph, and then we move to the right, so it is a distance of 1, 2, 3, 4, 5, 6. For our rise and for our run, it's 1, 2, 3. So if we create a fraction with 6 over 3, you can see that that also gives us 2. 6 divided by 3 will give us 2 as the slope. And that ends the session on graphing lines.